All right. Hello. 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 Yeah, awesome. All right, cool. I hope that. All right, now, truncus. Now, truncus compared to hyperbolas, what difference can you see? There's a square in the x and the denominator. So, as I said, hyperbolas, this one is not a square. Basically, it's in a degree of 1. Truncus has this difference here, all right? So that is the difference between those two, and we are going to do different examples that is going to show me the difference between those two. Now, it has something similar compared to the truncus properties, where there is some sort of inconsistency with the function, where one of the variables cannot be a specific number. What variable cannot take x in this scenario? 0. It cannot be 0 because 1 over 0 is undefined. So basically in 0, we have what we call again another asymptote. Yep. Where else do we see another asymptote? In the y equals 0, right? Why is that? Because there is no reciprocal that equals to 0. And then if you solve again for x, there is no value of an x that satisfy that 1 over 0 either. So again, I will still see two asymptotes. Now, tell me, what type of asymptote is x equals 0? Is it horizontal or a vertical asymptote? Vertical. So that plays always with your head because you always think about x as horizontal, but horizontal is the actual goes through the only touches an x point technically all the way through. So this is a vertical, and obviously this one would be horizontal. So again, we have it's like an imaginary axis of asymptotes. So if I draw, for example, my set of axes, I have again a vertical asymptote which is x equals 0, and I have another one. Good morning, Abby. Abby, did you sign in? Awesome. Y equals 0. Now, here is the difference between the hyperbola and the truncus. Now, where, in which quadrant did I have graph with my hyperbola? Which quadrants did you see graph in the hyperbola? Quadrant 1 and 3, right? That if it's a normal positive, if my A by dilation factor is positive. Now, with this one, x squared, I'm going to have only image or only graph in quadrant 1 and 2. All right, and this is basically what it's going. We're going to prove that in a second. So the truncus looks like this. Yep, only in 1 and 2, right? So it's like the will be graph in quadrant 1 and quadrant 2. All right, it's like two branches of this graph, and let's prove it as well. Let's graph this. Okay, so let's do a table of values always to prove this, x and y. And of course, there is no values on 0, so I'm just going to do 1, 2, and 3, minus 1, minus 2. All right? So when I have y equals 1 over, I'm going to start with this one. When the x value is 1, what will be my y value? 1. So it's like y equals 1 over 1 squared, which is 1. There you go. So let's do that one. 1 and, well, this is a very poorly done. Yep. 1, 1. What happens when is 2? It will be 1/4, right? So it's going to just, right? Uh, sorry. When x equals to, yep, x equals to is 1/4, kind of like getting lower and lower. Now, what happens when it's a very small number? What happens if now is y equals 1 minus 1 squared? What's 1 minus 1 squared? 1. So here is what it comes to. So minus 1, I was to have basically kind of like the reflection of the graph mirrored by that vertical asymptote, right? And it will be exactly the same when I will do 1 minus 2 squared, which is 1/4, right? So now if you do the other values with your calculator, you can actually determine that the graph will make this tendency. Now, notice that as I get approaching to, can anyone do in the calculator a value that is very, very large? Can you do 1 over, do it on the board, do it in your calculator, do 1 over, and let's say a very, very small number, minus 100 squared. What's that? Sorry? Yeah, what number is that in decimals? Convert it into a decimal. Yes, it does. Just change it into, yep. Yep. So it's approaching to which number? Now notice this. The larger the number in my denominator, or in this case, the smaller the number, I am approaching what number? 0. So the more numbers I give on this side, my graph is going to continue and will never ever, no matter what number you give in your calculator, it will be always a number that is closer to 0. Now, your calculator will break until the point that it cannot compute any more decimals, and it will say, stop giving me more numbers. You are actually getting 0 technically, because 0,000000001 technically is 0, but it's not 0. Does that make sense? Similarly, on the other side, if you do 1 over 1,000 or 100 to the power of 2, you will end up with a series of zeros, yeah, approaching to this side, but never crosses the x-axis. So therefore, there is no graph on quadrant 3 and quadrant 4. Does that make sense? This graph only exists in quadrant 1 and quadrant 2. Okay? Compared to the hyperbola, that the graph is like that. This is the hyperbola. This is the truncus. Okay? This is in the form of 1 over x. Yep. The other one is in the form of 1 over x squared. So far, so good? That is as simple as it is going to get. It's not going to get more complex than that. We're just going to learn now different properties of now hyperbolas. What do you think will be my domain? Again, sorry? You are correct. All real numbers except, because all the domain is any x value, right? And I can actually take any x value and I will get a graph. I don't care if it's not at the bottom, but I will still get a graph, right? And I'm looking only x values. How about my range? The range is the only one that's going to be different. No, because negative values on the range doesn't work. So which one then? Positive real numbers, because all the positive except which one? Except 0. Again, 0 is not included. Does that make sense? Because you don't see graph here. Remember, the range is looking at now the y values. In here, if I put y values, there is no graph on this side. Whereas in here, y, there is a correspondent value on x. Does that make sense? Does that make sense with the range? So, and again, look at this. As I approach, as x approaches the infinity to the right, or from the left, sorry, just get my language wrong here. As I approach my infinity from the left or from the right, x from the left or from the right, from the left, I am approaching technically, y approaches what? 0, right? But I say 0 in the positive side, right? Because it's not 0 complete. And as x approaches 0, y approaches the infinity. Yeah. As x approaches 0, the y approaches the positive infinity. Does that make sense? It's just the behavior of the graph, that's all. Now, again, similarly with my other transformations, I can find, again, the general equation. Now, the general equation will involve the translation, so that will look like y equals a x minus h squared plus k. All right? Now, remember, it has similar properties as the hyperbola. X equals k is what? What do you think? What does k will do here? It will be a vertical shift, right? But k here, similar as the hyperbola, will have a translation of my asymptote, right? So basically it would be my vertical asymptote. Y equals h, right? Which is, again, my horizontal translation. And that horizontal translation will be given by a horizontal asymptote. Okay? Oh, wait, am I doing this wrong? Probably. Give me 1 second. So again, the horizontal asymptote, it would be in that vertical translation, which is y equals k. The vertical asymptote goes to the corresponding horizontal translation, which is in x equals h. It just sometimes the words of horizontal and vertical translation can be a little bit, confusing. Now, this is super important. If a, again, is more than 0, something is going to happen with my graph. We already know that the graph will exist, is located in quadrant 1 and quadrant 2, right? But what happens if a is less than 0? Well, let's see it. So 1 over, sorry, a over x squared, right? So this is my truncus. Now, notice that as I increase that value of a, notice what's happening with my truncus. It moves away from the kind of the center. But as I decrease this number and I make the a value negative, look what's going to happen. Where do I see graph now? In which quadrants? 3 and 4. So this is super important. So when a is less than 0, the graph is in quadrant 3 and quadrant 4. Okay? Now, the domain of this, it would be always the real numbers except that value of h, right? Now, h, if there is nothing on it, will be 0. That's what we always say 0. But if there is a translation horizontally in h, that will be your domain. Again, if a is more than 0, the range would be k comma infinity. But if a is less than 0, the range would be minus infinity. Oh, I can't even do infinity, comma k. Those are just rules for us to, yep. So can I write the domain like a h is an asymptote and all real numbers except h? So say if h is 5 and you say all real numbers except 5. But will that not include all numbers like 4 and 6? Because you're only loading with 5. It does include 4 and 6. Because again, it's only 5 where the asymptote exists. So graph exists, approaching values to that asymptote on the 5, but nothing else. Most likely you will have a y-intercept. Let's do an example on how we use this at this year level. So that would be 1 over x plus 1 squared plus 2. All right, let's look at this example. The function is 1 over x plus 1 squared plus 2. Now, first thing to identify, this is a power of 2, which, what type of function is this? A truncus, right? If it was not power of 2, would be a hyperbola. Now, what else can I identify? I've got a plus 1 and I have a plus 2, right? Now, there is a h and a k value. Now, according to this, where are my asymptotes? Because those what they represent. What will be my horizontal asymptote? What is it? The horizontal would be in y equals 2. Yes? It's a translation vertically up to, but it's a horizontal line. Can we see it? My vertical asymptote. Thank you. Is the opposite, -1. We'd read that as the negative, right? So it's a vertical. Now move to the left on the -1. Let's draw this. So we got -1, 2, right? Now these create my new set of axes. I got a vertical asymptote in -1. Yep. My graph shifted -1 to the left with the asymptote. It moved up 2 units. And technically, this is now my new set of axes. Yep. Now, according to this, the A value is 1, and according to the rule, it says if A is more than 0, where would I see graph? Quadrant 1 and 2. So picture yourself that this is your new set of axes. So where is quadrant 1 and 2? At this one and that one over here, right? Forget about this one. This is your new set of axes. So technically, this is what's going to happen. This is your graph, right? And that's it. But I have an intercept here. Where is it? Here. So we need to find that y-intercept, right? We know how to do y-intercepts. We experts on that. What do we do, 0? X equals 0. So that would be f of 0, 1 over 0 plus 1 squared plus 2, 1 over 1 plus 2, which is? So it makes sense that is 3 here, and we just write down the coordinate. If 1 equals 0, if a equals 0, it would be nothing. It will be y equals 2. Because In order for you to have a hyperbola, this value a has to be different than 0. Otherwise, you will have all of these as 0. And there is no hyperbola. It's f of x2, which is a horizontal line. This is the level that we're going to explore truncus, same as hyperbolas, right? I'm not expecting for you to give me points of reference points. It's just like at least for you to know where the graph exists. This is year 11 content, guys, but it's intro for you to be more equipped for that methods unit. Let's do one more. F of x is 1 minus 4 x minus 2 squared. Okay, so this one, it has a writing of it a bit different, but it should not distract us from the actual definition of this. So start just, what I would like suggest here is arrange the expression better so you know exactly what's happening. So this is exactly as writing it down as minus 4 x minus 2 squared plus 1. Do you agree with that? It's exactly the same thing. So start analyzing things. I've got a minus here, that is this minus 4. I have this and that, and also I have a square, right? Now that square tells me that it's a truncus. I've got a horizontal and vertical translation that are my asymptotes, and now I have a minus 4. Now, according to this, the minus 4 is an a value that is less than 0. So where would I see my graph? In which quadrants? And 3 and 4. My graph should exist in these two quadrants, right? So that makes my thing a bit easier, kind of like to have an idea what to expect in my graph. Now, it's not going to be exactly like this. It's going to probably shift left and right, but we have already an understanding. Now, let's play with this. Asymptotes. Vertical. What is a vertical asymptote? X equals 2, all right? Yes, is the one that shifts us to the right, in this case to units, but it's a vertical line, right? My horizontal. In y equals 1 again, moves up 1, and that is a horizontal line. Let's draw that. So moves up 1 and 2 units to the right. So this again is my new set of axes. And you have to draw this set of axes, guys. If you don't do it and you don't label it, you lose marks, all right? This is my new set of axes. Now tell me, where do I see graph? 3 and 4, which are? And notice this. I will have most likely a y-intercept and an x-intercept on that side, and I will have an x-intercept on the other side. This kind of like makes the question a little bit more complex because I need to do more algebraic or operations. I need to use my potentially my the use of quadratics. Why do I know that? Because I got 2 points on x, right? So I need to solve that. So let's do it. It's not hard for us to solve. Let's start with the easiest one, which is my y-intercept. So that would be minus 4, 0 minus 2 squared plus 1. So minus 2 to the power of 2 is 4. Good job. Plus 1. And then minus 4 plus 4, minus 4 over 4 is? Negative 1 plus 1 is 0. So here I can fix my graph and makes it even better. What does that mean? What does it mean that the y equals 0? What does it pass through? To the origin. So my actual coordinate is 0, 0, which means that it's going to be even better because I don't have to worry about the x-intercept here. And then you fix it. Does that make sense? So I didn't. I used to have an idea, but I can fix it later. Then the next one, my x-intercept. So my x-intercept is making the y equals 0. So that would be 0 minus 4, x minus what? Minus 2, square plus 1. How do we solve this? What do we do first? Move the 1 on the other side. Minus 4, x minus 2 square. What else? Yeah. Get rid of the negatives. All right. It's easier. What else? What can we do? I'm going to then multiply the denominator, both sides, and then put it on the other side. So that will be x minus 2 squared equals 4. What do we do here? Square root it. You guys are very good at this. Equals? Sorry? Plus minus 2, right? And then we have x equals plus minus 2 plus 2, right? Two solutions, that x equals of 2 plus 2, which is x equals 4, or x minus 2 plus 2, which x equals, which makes sense that one of them is 0. Yeah, so then you write down your coordinate, 4, 0, and again 0, 0. So if this is 2, here would be 4, and that is your. So the only thing required when you do this type of graphs, if you see intercepts with the axis, you must solve it. But in the scenario there, let's say, for example, the graph does this. Let's say, for example, if it does that, you don't have to worry about x-intercepts or y-intercepts because there are none. Does that make sense? It's only if we have to calculate. And we're done. That is truncus. This is hyperbolas, and it works exactly the same. Now, to summarize all of this, you need to have already a map in your head of all of the functions. So I'm just going to write down all what we have done. All of the graphs that we have done. If I have f of x equals x plus 1, for example, what type of graph is that? You need to know this already. Is a linear graph? How do I do this? Right? Yep. The plus 1 again is up. What happens if I have something like this? F of x, x squared. What's that? Is a quadratic, and it does. Oh, I hate doing this. There you go. Yep. How about if I start increasing this? What's that? It's a cubic function. And what is the shape of that? It's not an S, so like a squiggly line. This one has a specific shape. What is the characteristic of this shape? It has something. It has a stationary point of inflection, right? Which means that at a specific point, it has like a flat part, right? It goes flat and then change. Now, this one is not from the bottom or from the top? From the bottom, because the A value is positive, so it does this behavior. Yes? And again, this point here is a point of in. What is a point of inflection, by the way? Sorry? So that is more like accurate. The second one is when the concavity of my graph changes. Concave down to concave up. Is this a point of inflection? Nope. It's a stationary point because again, at this point, the tangent line at this point is the gradient of that is 0, whereas the gradient here is positive and it continues positive. Something that you will learn as well in calculus next year. F of x, x4. What is that? It's a quartic. And what is the shape of that quartic? What does that look like? Sorry? Shape of a quartic? No idea. Sorry? What is the shape of a quartic? It's like a what? It's like a quadratic. As I said, it has similar characteristics of a quadratic, but the only difference is that it's kind of it gets flatter as it approaches this turning point. Right? Now, that's where we stop here, where there's no powers of 5. But if you would have a power of 5, what do you think will be the graph? Sorry? A square? No. What would be a power of 5? What would that look like? Similar to a cubic, but flatter here. What would be a power of 6? Similar to a quartic, but even flatter at the turning point. The graph doesn't change. It just changes in behavior in terms of like the shape, but it's the same style. We have seen also, tell me what this is. What's that? A circle. Where is the center of that circle? The origin. Yep. What is the radius of that circle? 1. Okay. Yes. And the last two graphs. What's that one? Hyperbola. What's the characteristic of a hyperbola? What do we have in this one? All right, we got this one. Yes, it goes quadrant 1 and 3, opposite quadrants. But what else? I'm missing two things. The asymptotes. If you don't draw those asymptotes, this is not a hyperbola. Okay? And the last one that we just learned, what's that? Truncus. And what do we see graph here? Quadrant 1 and 2. And what else about this graph? What else about this graph? Asymptotes, very cool. This is the summary of all the graphs that we have done so far. Linear, quadratic, cubic, quartic, circles, hyperbolas, and truncus. And we haven't even put here exponential graphs and logarithmic graphs, which we have already seen as well. Okay? Any questions so far about this? By now, you need to be able to manipulate all of these functions or all of these sort of like forms of representing an equation. There is already work for you to do as well on Canvas for truncus and hyperbolas. But now let's put a pause on that and let's go back to when we spoke about division, and let's redefine division of polynomials using a method that is super simple, but again, you only understand this when you have mastered again long division, the other method. All right, so I'm just gonna make a new page, and I'm just gonna write down here synthetic division. All right, so please pay attention. This is going to help everyone doing long division. All right, everyone place eyes on the board. Do not do anything. Just look at the board. Let's say, for example, my function is p of x, and I've got 2x cubed minus 5x squared minus x plus 3. And I'm going to divide that by x plus 3. All right? Pay attention. Synthetic division has specific rules. And those one of the rules are that I can only divide by a linear factor, right? Like x plus 3, x minus 2, x plus whatever, right? The other rule is that the coefficient of my leading term in my divisor has to be 1. Yeah, the coefficient of x in this case is 1. And also the degree of that is 1. X to the power of 1. So I can see 1s on this side. That is a must in order for you to divide synthetic division. Those must be 1. What I'm going to do next, I'm going to, exactly as the one before, do long division, right? But in a different form. Now, I'm going to just bring you to, I'm going to take this for a second. And when we did, when we took this one and we, let's say, to get to this factor, we basically substituted the opposite to this basically value on x to give me 0. So basically, I did f of minus 3. Do you all agree with that? To give me a remainder. So what was the remainder of minus 3? Can you do it in your calculator, please? Do f of minus 3 and give me what will be the remainder. Let's do the remainder theorem here. So there will be 2 times minus 3 cubed minus 5 minus 3 squared minus 3 plus 3. What's that? Did you get negative 3? Yes? Now, when I substitute that, this one, if, like technically, when you equal that to 0, is this value that I'm actually replacing in my original function. Minus 3, my remainder is 93. Now, if you would have done long division, that would have taken forever, and then to get to that negative 3 to prove that you've done it correctly. Now, let's do long division here. I'm going to take that value, negative 3, sorry. Yep. And I'm going to do a different shape to do my kind of like my process here to solve it. I'm going to do something like that. Yep. This is not division. This is not division. This is just another method. It's called synthetic division. Now, I'm going to take this one. That's what I asked you to do it. And I'm going to collect only the coefficients of my initial function. What are the coefficients? You tell me. Correct. So there are 2, -5, -1, and +3, the coefficients, right? So far, so good? Only with the coefficients. Now, what I'm going to do next is bring the first coefficient. I'm going to just bring it down, pass through that line. Okay? Drag it down. And then the next step, I'm going to take this value and multiply with the one that I dragged down first. What is -3 times 2? What is it? -6. And I'm going to collect this -6 and I'm going to place it here. Okay? Yep. Now, I'm going here now I'm not going to drag these minus 6. I'm going to add these two numbers. Technically, what I'm doing here is like an addition. Minus 6 minus 5 minus 11. Yep. And I'm going to repeat what I just did before. I'm going to take the minus 3 and I'm going to multiply with minus 11. So minus 3 times minus 11 is 33 positive. So I'm going to take that 33 positive and I'm going to place it here. And I'm going to ask myself again, minus 1 plus 33, 32 positive. Again, multiply that to minus 3 times 32, which is minus 96. So again, take this one and place it over here. And 3 minus 96 is, and ta-ta, this is my remainder, but this is not the end. I'm getting there. The solution, these values here, is what I'm interested. So I'm going to highlight that, right? And these ones, guys, the 2, the minus 11, and the 32 are going to be my solution, right? Now, when I divide by a cubic, right, going to divide it by a linear, what will be my quotient in terms of my variable? Would I get what order? It will be reduced by one order, would be x squared, right? So my first term in that sense would be x squared. What will be the next one? 11x plus 32. That's it. And then technically the solution of this is p of x follows the same thing, is x plus 3, which is my first linear factor, times that quadratic plus, minus 93. So if you had a linear factor that has a range of 0, it works exactly. I want to have an example with that. Yep. Sorry? This is a way, like, I want you to use long division regardless. In year 10, you need to master long division. But you can use this to see if you have done it correctly, all right? I don't want you to just like cut short and do this, all right? Because I need you to just, in long division, there are more skills that I'm looking at, which is your addition of like negative and positive values, attention to detail as well, simplifying like terms and all that. Like I'm looking at more skills than just this, right? You need to use this again to prove if you've done it correctly. But I don't want your answers to be just only this method. Does that make sense? Let's do another question. Yes, yeah, that's technical. Like I'm teaching this not for you to substitute long division, it's for you to complement it, basically, to prove that you've done it correct. And again, it takes 2 seconds to do this. What's the point of finding the remainder? Remember, the remainder, and this is just an example, yeah. But technically, what do I want that the remainder should be? What should be the remainder here? 0. I need that to be 0. So that's when I do the trial and error to find this. In this case, I just pick whatever number, and it gave me 93. It doesn't really matter. And this is just an example. I'm gonna give you one that actually the remainder is 0. So let's do that one. Let's do this example. Now, do you guys like this method? Synthetic division? It's a bit easier, right? Let's do it. 3x squared plus 17x squared, no, 3x cubed, sorry. 17x squared plus 6x minus 20 divides by x plus 5. All right. Now, let's prove that, again, that x plus 5 is a factor. So how do I prove that? Is by doing the remainder theorem. I need to get a remainder of 0. So it has to be 3 minus 5 to the power of 3 plus 17 minus 5 squared plus 6 minus 5 minus 20. Can you please do it in your calculator very quick and prove that that is 0? Yeah. Coefficients here, and now I'm going to bring down the 3. Yep. Then multiply these two. Minus 5 times 3 is minus 15. And remember, this is like an addition. 17 minus 15. Positive 2. Right? What do I do with that 2? Multiply it again. Minus 5 times 2 is minus 10. 6 minus 10, minus 4. And minus 5 times minus 4 is positive 20. And minus 20 plus 20 is? We have done it right. Look how easy it was. Now again, I'm interested on this only. So my P of X would be what? 3x what? X squared. Well, actually, technically, I should be writing my first linear factor, which is x plus 5, right? Then 3x squared plus 2x minus 4. Yes? And then I will take this as a quadratic and solve it. How do we solve that? Two numbers that multiply, so we got 3 times minus 4 is minus 12. And then two numbers that multiply minus 12 but also add up to 2. Two numbers that multiply to minus 12 and add up to 2. Can't think. Sorry? Oh, there are none. Minus 4, 5, 3, and nope. No. So how do we solve this? Substitution. Sorry? On my final, again, this is a very kind of like more tedious question to solve, but if I give you one question, you wouldn't have to do this at that level, all right? It's just to, at the end, you end up with your quadratic, and then you will find easy the two factors here. Does that make sense? Now, synthetic division, was it hard or easier? Super easy, 2 steps and it's done, right? But again, in the test, the question will say solve by long division. So it means that you have to demonstrate that you understand how to do long division. Regardless of that, in year 11, you don't really need to demonstrate either. You just need to solve the cubic, like factorize the cubic or the quartic or whatever you have in front of you. And then you'll do it with any method, right? Now, this gets more complex as, let's say, my divisor is no longer this a 1, right? I'm not going to go into that because I'm going to confuse you. If this is not a 1, guys, hear me out. If by any chance you have 2x plus 3, you cannot do long division. Sorry, you cannot do synthetic division. You can, but there is another level to do that. Like you need to then divide everything by 2, right? And then you have to do the whole process again with a fraction. So I don't want to overcomplicate this. If by any chance, hear me out, the divisor is in this form, do not use synthetic division. Does that make sense? Is that clear? Because I don't want that then that you get caught up on something that is not relevant at this stage. I need you to master long division. You only will apply at this level long division if this is coefficient of 1 and the degree of the and the order of this is 1, right? The moment that this is different, you need to use a different method. And I will potentially put that online on our Canvas page how to do it. But if you find it so confusing at this stage, don't do it. You will learn that probably next year with your next teacher. All right? Because at this stage, I need you to just master long division. So I will give you a lot of questions where this is linear, but I will also give you questions where this is not a linear. So where this is not a coefficient of 1, you will have coefficient of 2 or 3, which means that you still need to apply long division. Does that make sense?